Welcome to AI Peer Review. Today, we're diving deep into something that, well, it should be pretty straightforward in modern AI, but it's actually turning out to be fundamentally fragile. We're talking context adaptation.
Yeah, exactly. How these large language models, these LLMs, learn and adapt after they've been trained, when they're out there acting as agents.
It's become, like, the core challenge, hasn't it?
It really has. We've seen this big shift. Performance isn't so much about constant retraining, updating the weights of these huge models anymore.
Right.
It's much more about tweaking the input, the instructions, the memory, the prompt itself. That's the game now for building LLM agents.
But the ways we've been optimizing that input context, they seem to be failing. Sometimes spectacularly.
Which brings us to this really interesting paper on something called Agentic Context Engineering, or ACE.
ACE, okay.
And the paper argues there are these critical, deep flaws in how we currently optimize context.
So our mission for this deep dive is to really understand this ACE framework. How does it fix these problems?
And maybe more importantly, why is its core idea kind of revolutionary? ACE basically says, look, context shouldn't be these super concise, summarized prompts.
Okay.
They need to be comprehensive, evolving playbooks, rich with detail, domain insights, strategies, stuff the model can actually use.
Playbooks, not prompts. I like that. It shifts the focus from just hacking prompts to something more like strategic knowledge management.
Exactly. Knowledge management inside the LLM's input. It's a different way of thinking.
Okay, let's unpack this then. Section 1, the context crisis. Why are the current methods failing? We know context adaptation is appealing, right? The instructions are interpretable. You can add new stuff quickly.
Sure, the benefits are clear. But existing methods, the ones trying to distill the best context, they hit two huge walls. The first one, the authors call it brevity bias.
Brevity bias. Yeah.
If you use a standard context optimizer, something like GPA, generated prompt augmentation, the optimization process itself tends to just shrink the context down. It pushes towards the shortest, most generic instructions it can find.
But wait, isn't concise usually good? Efficient.
You'd think so. But you lose all the nuance. That conciseness, it sacrifices the really crucial domain-specific stuff.
Like how to use a specific tool or what not to do in certain situations.
Exactly. Those detailed heuristics, tool guidelines, failure modes. An intelligent agent needs that stuff for complex tasks. You end up with this high-level fluff that's useless when things get tricky.
Okay, so brevity bias is one problem. Losing detail. What's the second failure mode? You said it was worse.
Oh, yeah. This one's got a terrifying context collapse.
Context collapse. Okay, that sounds bad.
It is. This happens when you ask an LLM to basically rewrite its entire context, maybe based on recent attempts, trying to improve it iteratively.
So it looks at its whole memory or playbook and tries to make a better version.
Right. But instead of carefully integrating new lessons, it often just collapses it, tries to compress the whole thing into a much shorter summary. And that's where disaster strikes.
How badly?
Well, they have this really stark case study in the paper using the AppWorld benchmark. They had this context, this detailed playbook, over 18,000 tokens long.
18,000. Wow. That's a lot of strategy. And it was working well.
Yeah, pretty well. Getting like 66.7% accuracy. But then, at the very next optimization step, context collapse happened.
What did it do?
The LLM, tasked with rewriting that huge context, just compressed it down to, went for it 122 tokens.
Whoa. From 18,000 down to 122. That's not optimization, that's deletion.
It's catastrophic forgetting, basically. A massive, sudden loss of information.
Why? Why would the model do that? It seems so destructive.
It seems to be an artifact of that monolithic rewriting approach.
Yeah.
You have to get to rewrite everything based on the last few experiences. It defaults to trying to make a single efficient summary, and it just throws out all the specific hard-won details.
And the performance.
Plummeted.
Yeah.
Accuracy dropped to 57.1%, which, get this, was worse than the baseline model that had no context adaptation at all. That baseline got 63.7%.
So trying to optimize it actually made it significantly worse than doing nothing.
Exactly. It didn't just stop improving. The process actively damaged performance.
Wow. Okay, that really changes how you have to think about context. Maybe the lesson is LLMs aren't like us. They actually seem to like long, detailed context. They can handle the complexity.
It seems so.
Yeah.
They're good at pulling out what's relevant if you give them enough raw material.
Yeah.
So the goal shouldn't be compression. It should be, well, preservation and smart expansion.
The context needs to be that evolving playbook.
Precisely.
But hang on. If we're talking about feeding models 18,000 token context, Isn't that incredibly slow and expensive? How does that scale?
Ah, yes, the million-dollar question. And that's the tension ACE manages to resolve, which we'll definitely get into. But first, let's look at how ACE avoids this collapse. Section 2, the ACE architecture. It's all about modularity.
Okay, so how does ACE structure things differently?
It builds on earlier ideas like dynamic cheat sheet, which had adaptive memory. But ACE introduces this really structured agentic workflow with 3 distinct parts. It separates the responsibilities.
3 parts.
Yeah. Think of it like this. You've got the generator, that's the doer, then the reflector, that's like the internal critic, and finally, the curator, the librarian who files the lessons learned.
Doer, critic, librarian.
Yeah.
I like that. It makes the learning loop feel more deliberate. So walk us through it. The generator.
The generator is pretty straightforward. The task produces the reasoning, the plan, the actions, maybe uses some tools, but crucially, it also flags which bits of the existing playbook, which bullets were helpful or maybe misleading this time around.
Okay, so it generates the attempt and points out what worked or didn't from the current playbook. Then the reflector steps in, the critic.
Exactly. The reflector looked at that, traced the attempt, the outcome, the flag bullets. It critiques it. It tries to figure out why something worked or failed.
Root cause analysis.
Pretty much. It extracts concrete insights, like, the model failed because it used the wrong source of truth, or this filter didn't work because the input format was weird. They even show the detailed prompt for the reflector, asking for specific things like error identification and keen sight. It forces structured reflection.
So it's not just saying it failed, but it failed because... And the key lesson is...
Okay.
And the curator.
The librarian.
The curator takes those refined lessons from the reflector and decides what gets added to the permanent playbook. Its job is synthesis and integration.
But how does it avoid just making the playbook messy or redundant?
Well, that leads us to the core technical innovations. The curator doesn't just dump raw reflections in. It synthesizes them into compact delta entries, small, itemized changes. And this modular structure enables the 2 key things that prevent context collapse.
Okay, innovation number 1.
Incremental delta updates. This is the absolute key to avoiding collapse.
Instead of rewriting the whole thing. Exactly. No more monolithic rewrites.
Yeah.
ACE treats the context like a list of itemized bullets. Could be strategies, concepts, facts, failure modes, whatever. Each has its own metadata. The curator only generates and appends these small delta contexts, a few new or updated bullets.
So past knowledge, stuff that worked, is just left alone. It's preserved.
Precisely. It's never destroyed in a rewrite. Updates are localized. You're just adding new bullet points or maybe tweaking existing ones, like incrementing a counter.
Like editing a wiki page entry by entry, not rewriting the whole article every time? That sounds much safer. And probably faster.
Much faster, yes. We'll get to the speed gains later. It reduces computational costs, latency, enables fine-grained retrieval. Huge benefits.
Okay, so incremental updates preserve knowledge. What's the second innovation? How do you stop the playbook just growing infinitely and becoming full of redundant stuff?
Right, that's grow and refine. It's about managing that growth. New bullets are generally appended, letting the playbook expand. That's the grow part.
But the
refine part is about quality control. ACE uses semantic embeddings, basically, understanding the meaning to compare a potential new bullet against everything already in the playbook.
To check for duplicates.
Yeah, or near duplicates. If a new insight is semantically very similar to an existing bullet, the curator might decide not to add it as a new entry. Instead, it might just update the metadata of the existing bullet, say, incrementing a counter showing how often that strategy was helpful or harmful.
So it reinforces existing knowledge rather than adding clutter.
Yes.
It keeps the institutional memory relatively clean.
Exactly. Grow by appending, refine by deduplicating, updating metadata.
Okay, the architecture makes sense. It sounds robust, but does it actually work? Let's talk performance. Section 3, the metrics. Because the results seem, well, pretty impressive.
They really are. If you look at their main results figure, ACE consistently outperforms the baselines, standard in-context learning, GAPA, even dynamic cheat sheet.
By how much?
On average, they're reporting gains of about plus 10.6% on LLM agent tasks and plus 8.6% on domain-specific benchmarks. Those aren't trivial bumps.
10% on agents. That's significant. Let's dig into that agent case study app world. You said it involves interaction, multi-step reasoning. Sounds tough.
It is. It really tests the agent's ability to plan and adapt. So they took a standard agent framework, React, paired it with ACE for the context playbook.
And what model did they use? One of the giant proprietary ones.
That's the fascinating part. They used DeepSeek v3.1, which is a relatively smaller open source model.
Okay. And how did this smaller open source model with ACE do?
It matched the performance of the top-ranked agent on the leaderboard at the time,
Yeah.
IBM CUGA, on the overall average score.
Wait, match. Even though IBM CUGA was reportedly using the much larger, much more powerful GPT 4.1.
Matched it. And here's the kicker. On the harder part of the benchmark, the test challenge split, the really tricky scenarios, the ACE agent actually surpassed IBM CUGA.
Okay, hold on. A smaller open source model with smart context management, ACE, beat a system running on GPT 4.1 on the hardest tasks.
That's what the data shows. It's a powerful demonstration that the architecture of how the agent learns and manages its knowledge, that ACE playbook, can potentially make a bigger difference than just raw model size, especially for complex strategic tasks.
That's huge. It suggests maybe we don't always need the absolute biggest model if we have smarter ways to guide it.
It certainly points in that direction. And another really important practical point, ACE achieved this without needing labeled data, ground truth supervision. It learned just from natural feedback, did the code it generated run successfully or not. That makes it much cheaper and easier to deploy.
Okay, so strong results on agent tasks.
Yeah.
What about those domain-specific benchmarks you mentioned, like Finer and Formula?
Right. These tasks need the model to really understand specialized concepts like XBRL for financial analysis. It's not just general reasoning.
And how did ACE do there?
Again, really well. Using ACE for offline adaptation, basically, building the playbook beforehand gave an average boost of almost 11% compared to methods like standard ICL or TEPA.
So it confirms that for tasks needing deep, specific knowledge, having that rich, structured playbook built by ACE is super valuable.
Definitely. It proves the concept isn't just for interactive agents, but also for knowledge-intensive query answering or analysis.
All right, now let's circle back to that cost and speed issue. We established ACE uses potentially very long contexts, the playbooks. But you said it resolves the tension. How?
Through those incremental delta updates we talked about, they aren't just good for avoiding collapse, they are incredibly efficient.
How efficient?
The paper quantifies it. On average, ACE had an 86.9% lower adaptation latency compared to other adaptive methods like GPA or DC.
Whoa, nearly 87% faster. That's huge.
It is. Looking at specific examples, they saw like an 82% latency reduction versus GPA for offline adaptation on AppWorld. And for online adaptation on Finer, it was over 91% faster than dynamic cheat sheet.
So you get better accuracy, and it's dramatically faster to update the context. That completely flips the script on the scaling concern.
Exactly. It shows that scalable self-improvement, higher accuracy, and lower overhead can actually go hand in hand if you have the right architecture.
And okay, but what about just the cost of using the long context during inference? Even if updating is fast, does running the model with an 18,000 token playbook slow things down?
That's a fair point, and the paper touches on it. While ACE does generate longer contexts, they note that modern AI-serving infrastructure is getting much better at handling exactly this.
Things like KV cache optimizations.
Yeah, KV cache reuse, context compression techniques, efficient attention mechanisms, offloading. The cost of dealing with long contexts isn't scaling linearly anymore. The amortized cost is coming down.
So the playbook approach is becoming more practical, not just theoretically better.
Right. It is moving from a research idea to something potentially viable in production, especially where that deep, evolving knowledge is critical.
Okay. Before we wrap up with the big picture, are there any major limitations to ACE? Where might it stumble?
There's one key dependency they highlight: the quality of the reflector. Remember the internal critic.
Right. The module that analyzes successes and failures.
ACE really relies on that reflector module, which is powered by an LLM itself, being good enough to extract genuinely useful, non-spurious insights.
What happens if the reflector isn't very good?
Well, if it generates noisy or just plain wrong lessons, especially in domains where the feedback signal is weak, like it's hard to tell if an answer was truly good or bad, then the curator might start adding junk to the playbook.
So you could end up polluting the context with bad advice.
Potentially, yeah.
Oh.
If the critique isn't sharp, the playbook could become harmful rather than helpful.
Yeah.
So you need a reasonably capable base model for the reflection part to work well. It needs a decent brain to critique itself effectively.
Makes sense. Garbage in, garbage out, even for the learning process. Okay, let's pull back. Section 4. What does this all mean? What are the big takeaways here?
I think the main takeaway is this fundamental shift in thinking about context. We need to move away from trying to find the perfect, short, static prompt
Towards.
towards building these dynamic, itemized, self-evolving playbooks. That seems to be the path towards more reliable, more capable LLM agents.
From prompt engineering to playbook curation.
Exactly. And the broader implications are pretty significant for the future of AI systems. First, continuous learning.
Right. Updating the context playbook via ACE is way cheaper and faster than constantly fine-tuning the entire model's weights every time you learn something new.
Dramatically so. But also, think about responsible learning, because the playbook is made of these itemized, human-readable bullets.
You can actually understand what the model has learned.
Yes, and you can intervene. Imagine a strategy becomes outdated, or maybe some piece of information is found to be incorrect or biased or legally problematic.
With a monolithic model, fixing that is hard, maybe impossible without retraining.
But with ACE, you can potentially just go into the playbook and update or preen those specific bullets. It offers a mechanism for selective unlearning, which is incredibly important for compliance, safety, and just maintaining the system over time.
That interpretability and targeted control is a huge advantage. Okay, final thoughts.
Well, building on that earlier point about model size,
Yeah.
we saw ACE enabling a smaller open source model to match or beat a giant proprietary one on really tough agent tasks.
Yeah, that was striking.
So here's a final provocative thought for you, for everyone listening. How much does the architecture of knowledge management, this idea of the evolving playbook, actually start to outweigh raw model size or parameter count in building the next generation of capable AI applications?
Are we maybe focusing too much on just scaling up models when the real gains might come from smarter ways of managing and accessing knowledge within the context? Should your next investment be in a bigger model or in a smarter context architecture like ACE?
Something to definitely think about as you design your next AI system.
Indeed. A fascinating look at agentic context engineering. Thanks for unpacking that.
My pleasure. Lots to consider there.